Let's start the solution. Sin theta is equal to minus 1 over under root 2. We know that sin theta is negative in third and fourth quadrant. Given that theta is not in quadrant third, this implies that theta must lie in quadrant 4. Now we use the sign of trigonometric function according to fourth quadrant. It's easy to understand. Sin theta is negative. It means theta is lies in either third quadrant or fourth quadrant. In the question given that theta is not in third quadrant, the only choice for theta is in quadrant fourth. It means in this question theta lies in fourth quadrant. Now we find the value of trigonometric function according to fourth quadrant. We know that sin theta is equal to perpendicular over hypotenuse. This implies that P is equal to, here we can write P is equal to 1 and H is equal to under root 2. By Pythagoras theorem, H square is equal to P square plus B square. The value of H is under root 2. Under root 2 square 1 square plus B square. 2 is equal to 1 plus B square. 2 minus 1 is equal to B square. Here B square is equal to 1. Taking square root on both sides, B is equal to 1. Now we find the value of remaining trigonometric function. First of all, cos theta. Cos theta is equal to B over H. And in fourth quadrant, cos is positive. The value of B is 1 and the value of H is under root 2. Tan theta is equal to perpendicular over base, and in fourth quadrant tan theta is negative. The value of tan theta is equal to minus 1 over 1 is equal to minus 1. The reciprocal of cos theta is sec theta. Sec theta will be equal to under root 2 and the value of tan theta is cot theta. Cot theta is the reciprocal of tan theta and the reciprocal of minus 1 is also minus 1. The last one, cosec theta. Cosec theta is the reciprocal of sin theta. Cosec theta is the reciprocal of sin theta, and given that the value of sin theta is minus 1 over under root 2, therefore the value of cosec theta is only minus under root 2. So we have 5 remaining trigonometric functions. Now we solve another question. Question number 5. If cot theta is equal to 15 over 8 and the terminal arm of the angle is not in quadrant first, find the value of cos theta and cosec theta. This another form of the question. Cot theta is given and tell the terminal arm of the angle is not in quadrant first, and we have to find only values of only two trigonometric functions. We have to find the values of only two trigonometric functions, cos theta and cosec theta. Similar to fifth part of question number 4, given that cot theta is equal to 15 over 8, and we have seen that the value of cot theta is positive, and we know that cot theta is positive in first and third quadrant. Given that the angle is not in quadrant first, the only choice for theta angle is a third quadrant. We can write this statement: cot theta is positive in first and third quadrant, given that theta is not in quadrant first. This implies that theta is in quadrant third. Now we use the relation cot theta is equal to 15 over 8. Cot theta is reciprocal of tan theta, and tan theta is equal to perpendicular over base. Therefore cot theta will be equal to base over perpendicular. This implies that b is equal to 15 and p is equal to 8. Now we use Pythagoras theorem. H square is equal to p square plus b square will be equal to, the value of p is 8 and the square of 8 is 64, plus the value of b is 15 and square of 15 is 225. After adding these values, we have 289. H square is equal to 289. Taking under root on both sides, h will be equal to 17. Here we have find only two values. First is cos theta. We know that cos theta is equal to base over hypotenuse, and in third quadrant the value of cos will be negative. B is equal to 15 and H is equal to 17. And cosec theta, second value we have find cosec theta. Cosec theta is equal to, cosec theta is reciprocal of sine theta and sine theta is perpendicular over hypotenuse. Therefore cosec theta will be equal to hypotenuse over perpendicular, and in third quadrant cosec theta is also negative. Therefore the value of cosec theta will be equal to minus 17 over 8. These two values we have to find.